Continuing lesson 6.6 on describing dilations. We look at the key concept, kind of recapping some things here. So dilation, either we're enlarging or shrinking something. So if the scale factor is greater than 1, then it's an enlargement. So this blue rectangle was what we started with, and then we made it bigger. If both of these shapes are drawn, you can compare, if you have a straight side like this, you can compare the side lengths to figure out what your scale factor is. Remember, it's the new over the original, or the new over the old, if you want to look at it that way. So our new side length is 2, our original side length is 1, so our scale factor is 2, which basically means, you know, we're increasing it twice as much, or 200% increase. Scale factor is between 0 and 1, then it's a reduction. We're making it smaller. And again, we could compare side lengths here. Side length was 4, now it's 1. So our new side length is 1, our original side length was 4. So that's a 1/4 scale factor. It's 25% the size of what it was to begin with. So we're going to look at the do you know how. Do you know how number 4. Figure 3 is the image of figure 1 after dilation with center at the origin. What is the scale factor? So we're looking at figure 1 and figure 3. We're starting with figure 1, going to figure 3. Those have straight sides at the bottom, so if you want to just compare those sides, you can. So originally the side length was 1 at the bottom here, and now it's 4. So our scale factor, we could do 4 over 1, which is the same as 4. And basically what's happening, we could say the sides on figure 3 are 4 times as big as the sides on figure 1. Again, when it says explain, we can't just put 4 and move on to the next problem. That's not explaining. So make sure you give a sentence explanation of how you came up with that answer. Okay, again, like we did, you could say, you know, the bases on the triangles, 1 is 4, 1 is 1, and the new divided by the original is 4 over 1, which is the same as 4. That would be fine also. Look at number 5. What are the coordinates of figure 2 after dilation with center at the origin and scale factor of 3? So make sure you're looking at the correct figure here. Figure 2 is the blue one. So this, going to look at the coordinates first of all. So this coordinates here would be 2, 2, 4, 2, and 3, 4. We're doing a scale factor of 3, which means we're going to take each one of those numbers and multiply them by 3. So 0.22, we multiply both of those by 3, would go to 6, 6. The 4, 2, again, multiplying both of those by 3, would go to 12, 6. And the point at the top, the 3, 4, multiply both of those by 3, would go to 9, 12. They did not label the points like A, B, and C or anything, so all we could really do is list each of the coordinates, 6, 6, 12, 6, and 9, 12, as our answer for number 5. Now if we look at number 6, which figures represent a dilation with a scale factor of 1/2? So Notice the word figures. We could have more than one set here that works, potentially. And again, what you can do, since we have a straight side at the bottom, you can just look at the side lengths. So we already talked about the 1 and the 4. The other one, the base of this blue triangle, has a length of 2. So we can think about, you know, which one is half of the other size. And just remember, to make it half, you have to go from bigger to smaller, because we're making it half as big as it was originally. So one way of doing that, we could go from figure 3 to figure 2. Figure 3 to figure 2 would be one option, because we're going from 4 to 2. Remember, it's new over original. Our new side length is 2, our original side length was 4, and 2/4 reduces to a half. Another option would be figure 2 to figure 1. Figure 2 to figure 1, because our new side length is 1, our original side length is 2, and that already is showing as a 1/2 scale factor. One thing a little bit different that we could also see is like this problem, where we're trying to figure out what the scale factor is. These sides are all at angles. If they're all at angles like this, what you have to do is look at the coordinates. Like we did earlier, you have to look at, you know, what are the coordinates for point A, what are the coordinates for point A prime, and then, for example, compare your x coordinates to each other. Okay, just make sure you remember to put your new coordinate over your original coordinate when you're working that out. So this gives you an idea of how to work with dilations.